So real quick, I just want to introduce myself. My name is Dave Sharp. For the last 6 years, I was a designer with a company called littleBits. And littleBits is a library of electronic building blocks, kind of like high-tech Legos for circuits that let kids build different kinds of electronic inventions and gadgets. And I worked with teams that would develop the kits specifically for schools. So we would come up with different kinds of inventions and come up with different kinds of lessons with the aim of getting kids excited about science and excited about engineering and excited about being curious about their world. So we did a kit about music a couple years ago, which was a lot of fun. That one was more about electronic music and synthesizers. But then I've also recently, through friends at littleBits, got introduced to the folks at Loog. And I've gotten really excited about the work they're doing. So I'm really happy to be here today and to be able to share and talk a little bit. Right now, today is not really going to be about littleBits at all. Today is going to be more about the science of sound, and we're going to be looking at So here's what we're going to look at today. First thing we're going to look at is what is sound, which I think is an important part of understanding sort of the basis of music. Is what is it? Then the next thing that we're going to look at is how do you use sound to make music? How do you use sound as a tool for making? How do you make different kinds of sounds? And then the last bit is going to be about tips for making your own instruments. Because everything that I'm going to show you today, with the exception of one guitar, all of the experiments and things that I'm going to show you today are made out of stuff from around the house. Yes, Jason, we just started. All I've done so far is just introduce myself. So all the stuff that we're going to do today is from stuff that's around the house. And so hopefully this is stuff that after you sort of learn the science behind it and how things work, you can then take that and with the materials that are around your house, you can experiment and build some of your own instruments, your own sort of wacky and weird experimental instruments. So the first thing that we're going to do, we're going to talk about what is sound. Does anyone have any guesses? If someone asked you, what is sound? What is it that how would you describe what sound is to them? Let's see. Comments are a little bit delayed, so we'll wait a second. And all right, so sound is vibrations in one really easy way. Yes, waves. Waves and vibrations are different ways of describing the same thing, and I'm going to have a demonstration that kind of explains that in a second. So one way to sort of think about it is put your hand on your throat when you're speaking, and you can feel, if you just sort of put your tips of your fingers along your throat, you can feel that vibration, right? And it is those vibrations that are making sound. And I want to sort of take another second here. We're going to show you a way that you can also sort of visualize vibrations. So right here, I have a simple wooden stick, right? And you take this stick, and the first thing I'm going to do is I'm just going to press down and I'm going to let go. And you can see those vibrations. And sort of one way to think about this is like a really big guitar string seen very up close. And you'll notice that what these vibrations are doing is it's going up and it's going down, and it's going up and it's going down. Just like a wave does. A wave goes up and a wave goes down, and a wave goes up and a wave goes down. And I saw someone else in their comments said something about frequencies, and we're going to talk about frequencies a little bit. Basically what a frequency is how frequently, how often does it go up and then down? Does it go up and down once every second? Does it go up and down 20 times in a second or 1,000 times in a second. And that frequency is a really important part of sound and a really, really important part on music. And so I wanted to start off with another little experiment here that we're going to do as a way to be able to visualize sound as waves and as vibrations. So what we're going to do is we're going to light a candle. And if you want to do this at home, make sure you got your parents around to light the candle. So what I'm going to do is I'm going to take a speaker here and I'm going to play a very low frequency out of this speaker. I'm going to play 75 hertz, which means that this is a sound wave. This is a sound wave that vibrates, that goes up and down 75 times every second. And you're going to be able to see in the candle flame the effect of that. So here's the candle flame. So you can see those vibrations are almost going to blow that candle flame right out. And those are those sound waves moving forward out of the speaker right in to that. And there have even been, I saw some really cool inventions, which are fire extinguishers that don't work by shooting gunk out of a hose, but they're fire extinguishers that work with ultra low frequencies that essentially use sound to blow the fire out, which is super, super mind-blowing. All right, so that was a really low frequency, and that was a great way to be able to see the effect that those sound waves have moving through the air. How does that happen? And I think that's sort of one interesting thing here is that, like, we've got a speaker, we've got something vibrating, or let's say we have a guitar string. How does that translate to, say, that candle flame moving? Or if your guitar string is, grab one right here. So there's, here's our guitar, and you can see when I pluck that string, you can see that shaking. But just because something is shaking, how come I hear that? And that's where the waves come into effect, because you don't need that candle anymore. When the guitar string is vibrating, or when the speaker is vibrating, essentially what it's doing is it's bumping into molecules in the air. And so the string vibrates and it hits a little molecule of air, and then that molecule of air goes and knocks into another molecule of air, and they just keep on knocking into other molecules of air until it gets all the way into you. And that's where you can hear it or you can feel it, is you're actually feeling molecules bumping into you. And that's sort of like a chain of dominoes that has gone down the way. And it's a really interesting thing is that sound can only happen in places that are that have stuff to bump into each other. So if you go into the vacuum of space where there is no air, or in some places of space where the matter is so far apart that one molecule can't really bump into another, there's no way for sound to travel. And so when you sort of see movies like Star Wars and their things, they're the lasers and pew, 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 and explosions, and you hear all of that. Truth is, in space, it would be silent because there's nothing to transfer that sound. And another interesting thing is, consequently, it's not just air that can transfer sound. So this stick that we were looking at earlier happens to have these majestic creatures on them, whales. And you've heard whales or dolphins can communicate underwater. Water actually is really good at transferring sound. It's actually better at transferring sound than air is. The sound waves can actually move 4 times faster through water than they can through air. And why is that? That's because all of those water molecules are closer together, which means it's much easier for one to bump into another, to bump into another, to bump into another. So that energy gets transferred from the source of the sound to somewhere else much quicker. And you can even take the call of a humpback whale can travel thousands of miles. And so imagine being able to sort of yell out your bedroom window to a friend that was thousands of miles away, and they would hear you yelling to them. That's sort of what it's like with humpback whales and sound moving underwater. Sound can also move through solid things, not just air and water. I think one great example of that is if you have people who are talking in the next room, sometimes people might put their ear right up against the door. And that's not just getting closer to the sound, but what's happening there is the sound waves are actually causing that door to vibrate a little bit. And if you put your ear right up against the door, the vibrations from the solid door are making the bones of your ear and the bones of your face vibrate a little bit too. And so that sound is going through the solid door right into your solid head. And so sound can travel through all sorts of different materials. And when it travels through these different materials, it's gonna change how it works. It might travel faster, it might travel farther, or it might not travel so far or travel so well. A couple other things to sort of think about in the basics of sound is another important thing is that if sound comes from vibrations, that also means that when you stop the vibration, you stop the sound. So as soon as I put my finger on that sound, there's no more vibration, so there's no more sound. Same thing here, I might have a bell. And you see it will continue to vibrate after I ring that bell. As soon as I put my hand on the bell, the sound stops. So we looked at guitar strings, we looked at bells. There's a couple other interesting ways that you can make sound around you. And so these can be sort of ingredients you can think about when you would build a musical instrument later, and we'll dive into each of these in a little more detail. But one thing I wanted to get here, let's see, a couple things. We've got one way that you can make sound, and this is one we're pretty familiar with, is just with impact. This is like drums or xylophones. So, and in a little bit, we're going to look at the different ways that you can create different notes and different sounds with each of these tools. Another thing that we're going to look at is being able to make sounds with air. And so that's an interesting one, is because when you pluck a guitar string, you can see that guitar string vibrating. And you say, oh, that's vibrating, that's why that's making noise. And when you bang on a bell, you can feel the bell vibrating, and you think, oh, okay, I can feel that bell vibrating, that's why it's making noise. And this is a curious one. So I'm just blowing in the top of a bottle. So how is that making noise? And that's making noise because when you blow along the top of this bottle, you're blowing some air into the bottle. But there's no other hole in the bottle, so the air doesn't have anywhere to go. So what happens is you blow some air, and it crams a little bit too much air in there. And once there's too much air in there, the air wants to get let out. And so it's able to push against the force of your blowing, and so a little bit of the air comes out, and the pressure in the bottle goes down, which means that there's more room for air for your blowing, so that it goes up and down. It's the pressure inside that bottle is going up and down and up and down. And when it goes up and down at the right frequency, it's going to start to make a noise. Another interesting one that you might have seen at the dinner table sometime. And this one sometimes takes us a second because I need to get my fingers a little bit wet. So this one uses wine glasses, but you can... One second, hold on, need a little more water. I got a jug of water handy here. Oops, making a mess. Already making a mess. All right. So what's happening here? How are we making noise with this? Well, one of the things that's really important is that I made my finger a little bit wet. And if you could get really, really, really close to my finger, you would see that there's like the fingerprint. And one of the things that your fingerprint is really useful for is that when your hand gets wet, it gives you kind of an extra grip on things. That keeps it from, that way you're not sliding and slipping and dropping everything every time your finger gets wet. And so what happens when you rub a wet finger along the top of a glass is that the water lets your finger slide for a little bit, but then all the ridges in your fingerprint catch the glass and slow it down, and then the water slides a little bit, and so it's basically, in a very fast way, your finger is starting and stopping with friction as it's going along the top of the glass, which is creating those vibrations, which are then going to create the noise from the wine glass. All right, and then let's see, one more thing in terms of the basics here. Another wind instrument. So we've got this horn, which is pretty loud. And so how does that work? Well, this one's actually kind of difficult to take off, or take apart. But I do have this other one, which is sort of falling apart. So this is an old car horn. So back in the days of early cars, and also in sort of stagecoaches and things, you would pop this horn on the side of your car, and rather than having to blow every time someone got in your way, you would just sort of press this ball. So we're going to take it apart, and we're going to see, how's it making vibrations? How's it making noise? So if we look closely inside the horn, you can see this thing right here, this little reed, and it's made of two parts. You'll see this rounded part here, and then this flexible metal part right here, right? And similar to when I was blowing into the bottle, and pressure would build up and then it would come out, and then it would build up and it would come out, and it build up and come out, and how it built up and come out would generate waves. This works in a similar way in that it lets a certain amount of air through until the pressure closes it, and then you blow and the pressure increases and it lets a little air through, and then over and over in that cycle, in that sort of frequency, it starts to generate a noise. So sounds a little bit like a kazoo. And then so now we just, rather than having to do that and blow on it, we can attach it to this guy, which blows for us, so that we're free to pay attention to driving as we do it. And the other thing that happens here, and we can talk about this a little bit later on when I talk about resonance and things like that, is that you'll notice it sounds a lot different and a lot louder than when I was just blowing on it by hand. And that has a lot to do with the fact that it's blowing into a horn, right? And so something that the length of this tube is doing is changing the vibrations, and then the shape of the tube is also changing the vibrations in a way that makes the sound louder to us. And I'm going to explain that a little bit when I get to resonance. So let's see. Oh, and resonance is next on my list. So now we'll talk about resonance. So those are the some of the basic ways of generating sound. And the next thing is, well, so we've got the ingredients. If you think about the ingredients of a guitar, first ingredient is we've got something that vibrates. Okay, but a guitar is more than that. A guitar is more than just strings. Like, for example, there's this sort of hollow body here, and there's a hole. So what's that all about? Well, vibrations are part of what makes an instrument, but part of also is that it's important that people around you can hear it, especially in the days before you could plug all your instruments into an amp. It was really important that your sound was able to be sort of rich and loud towards the audience around you. And so part of what this box does, without the hollowness of it, is create resonance. And so what happens is when I pluck this string, you'll see here down at the bridge, which is where the string attaches to the base of the guitar, that bridge vibrates. And then it causes this whole body here to vibrate. And so now I not only have just a little string vibrating, but I've got a string and all of this flat surface vibrating. So that's a lot more stuff to knock the air around and create noise. And then the other part of it is that with all of this hollow space inside, all of those waves are bouncing around inside that hollow space. And sometimes those waves come together, and it's sort of like teamwork in that they start to wave together, which gives those waves even more power when they are going together. And so you actually it is focusing that energy in a way that makes it louder for us to hear. So that's how resonance works to increase the sound of an instrument. And the same thing here is what a horn is doing. It is sort of concentrating and focusing all of those sound waves so that by the time they're coming out with this sort of unique shape here, it's focusing all of that energy into one direction and letting those waves kind of come together and do that teamwork where they reinforce each other to make the sound louder. And then I wanted to do one sort of somewhat goofy experiment here, which is sort of the other side of resonance, where resonance is one way that you can sort of amplify a sound. But the same thing that you can do with sound in a space is you can deaden it. You can filter parts of it out. You can essentially block certain kinds of noise. So you might sort of be able to hear me now. Now I'm putting you in this jar. And there, now you're in a jar. And things probably sound a bit different. And that's because the sound waves now have to travel and they hit that jar. And this plastic jar absorbs some of the sound waves and it distorts some of the sound waves. And then when the sound gets inside of that jar, they start bouncing around in different ways. And so that's one way that it sort of changes and filters the sound. And if you were to ever go into a recording booth in a studio, something you'll notice if you look around on the walls is the walls are oftentimes filled with a lot of foam or stuff that looks like egg crates. And that is sort of a similar idea of they don't want too much resonance or distortion happening inside of that recording studio. So what they're going to do is they're going to put all of these things which absorb that extra sound to keep it from bouncing around and making everything really, the sound really sort of messy. And so in some circumstances, you want to use that resonance to be able to focus and amplify the sound. And then in other instances, you want to use sort of the space in order to deaden and mute the sound. Let's see, what else is on the list? Oh, so there's another sort of interesting part of this is that so we've got sounds, moving from the thing that's vibrating, be it a bell or a guitar string. How does that make us hear things? And so how sort of hearing works, you might have heard of an eardrum. And essentially, an eardrum is sort of a flat surface, like the surface of a drum, that's inside your ear. And when those air molecules are bumping up against one another, they will travel into your ear, and eventually they'll bump right up against that flat surface of your eardrum. And that flat surface of your eardrum then connects to some other parts of your inner ear, which cause these little hairs to vibrate. And so that's a way of translating the movement of the air into little parts of your body that are moving, which is going to then send electrical signals into your brain, and those electrical signals are interpreted as music. And I think it's a really interesting parallel with something like an electric guitar. So I'm going to plug us in here. With an electric guitar, you'll have something that is vibrating like a string. And then here in the middle, see, this is a part that you don't see on an acoustic guitar. This is the pickup. And this, in a way, is kind of like the eardrum, in that it senses the vibrations of the string. And it uses sort of magnets and magnetic fields to sense the vibration of the string. And those vibrations of a string are then translated into an electrical signal, which is sent through this cord, which is kind of like the nerve that runs from your ear to your brain. And then this amp then interprets that electrical signal as noise. And so it's the same thing that happens in your ears, that your eardrum vibrates. Part of your eardrum converts that to electricity, which runs down your nerve into your brain, and then you interpret that as noise, as sound. And that's also how microphones work. Microphones have a little, almost like an eardrum in them that moves when the sound hits it, and it converts that into electrical signals. I think it's important to note also that the other way that you can perceive sound is you not only hear sound, but you can feel sound. So I mentioned to a few of the folks who were here at the very beginning that a thunderstorm had rolled through where I live about 20 minutes before this. And there was a lot of thunder, a lot of lightning very close, caused the whole house to shake. And I could feel it in my chest. And so you're not only able to hear sound and hear music, but it is something that you can feel in your whole body. And in particular, there are deaf musicians out there, and I encourage you to explore that a little bit, who have a different sort of relationship with music, and it is one that is much more about it reflects their experience of being able to really feel music, feel the vibrations in their chest. Feel the vibrations in their body. So there are a whole lot of ways that we can experience music and experience sound. All right, let me just quick. Okay, I'm going to try and move things along here. Next thing I want to talk about is how do you sort of control sound? And so we made sound, but part of making music is being able to, just a quick comment here, lower frequencies are easier to feel, right? And that's true. And one of the things that when I was playing that sound of the speaker that caused the candle flame to go out, that was a very low frequency. And those low frequencies can really sort of push a lot of air with a lot of power, and that sort of bass is something that you tend to feel very sort of deeply in your body, and you can kind of feel those things resonate in your body. So I wanted to do a quick demonstration about frequencies. There's sort of a spectrum of frequencies. So like I said, that it's things you can measure a frequency in something called hertz, which is how often does something vibrate every second. And so if it just goes up and down once every second, that's 1 hertz. We can start to hear things at about 20 hertz. So things when they vibrate at about 20, actually might be 40. I've gotten my numbers mixed up. But around the very low range of 20 to 40 hertz, I believe you can start to hear things. And those are those very, very low, deep sounds. And you can go high. Once you start to get above 2,000 hertz, that's where hertz hurts. There are so 20 hertz is the correct number. Thank you. So once you get to a certain frequency, when things are really high pitch, that's actually where it can start to hurt, and that's in part they've discovered that there are certain parts of your brain which really do not like those super high frequencies. So it's not just the volume. There's a reason why that high-pitched whine, even if it's a little bit quiet, is really tough to listen to, and it's because parts of your brain really don't like those very high frequencies. So first thing I wanted to do was go back to this stick as a way to sort of think about frequencies. And so when I make this stick really long and give it a whack, you can see it, maybe help if I'm in front of it, dark shirt, you can see it vibrating back and forth. And now I'm going to cut it in about half, and look at how it changes. Gets a little bit faster, a little bit faster, a little bit faster. So now you're not really seeing this wobble back and forth, but you're seeing it's almost like a blur for a second. And a little bit faster. And you'll notice that you're also starting to hear a bit of a sound difference. And now this isn't the most perfect musical instrument. It's a yardstick and a board. But you see the difference between that, which doesn't really make a sound I can hear, and then really short, makes that quick little buzz. And so one of the things we can do is we can change the length of something as a way to change how it vibrates. And so that same sort of principle plays out in a guitar, right? That's how we're able to play different notes on the guitar. When I play the note without touching it, then maybe I cut that length of that string in half. By shortening that string, I'm causing it to vibrate at a greater frequency, which is going to create a higher pitch. And so that's the whole sort of magic of how the guitar is built, and with this fretboard, is that you're using your fingers to be able to change the length of each one of those strings. So that's how you're able to just really quickly, with your fingers, create all sorts of different notes. What's the next? Oh, yes. So all sorts of different notes. This is sort of plays true not only in a guitar, but any other instrument in any other way that you might make something vibrate. You can change those vibrations to change the notes that you're making. So first thing that we're going to do is grab my bottle. And so you'll see here a nice deep. So now I'm going to pour some water in, and I wanted you to be able to see the water level here, but I was out of food coloring, so I used beets, which I thought was really funny because this is a live stream about music, and I used beets to color the water. Can you tell that I've been waiting all day to make that pun? Okay, so now here what I've done is I've added water, You can see that it's higher. So now I can add a little more water. And so now it's much higher. And so this is a little different than a vibrating string. So how is this working? Well, when there's a lot of air in here, it takes a long time. This can take a lot more pressure. There's a lot more space for it to build up extra air. So when I'm blowing in, it takes longer to build up pressure and then push the pressure out and then build up pressure and push the pressure out. And as I reduce the amount of airspace in the bottle, there's less space for it to build up pressure. So it has to release that pressure more frequently, which means that the vibration is going to be happening more frequently. And that means it's a higher frequency, which means it's a higher sound. And wanted to demonstrate that in another way with water glasses. See if I can do this without knocking everything over. So this is an easy way that you can actually make different notes. Let's see, can we see them all here? Yes. And so one thing I'm going to do here is, if I can find where I put it, oh, here it is I'm going to use a measuring cup. And I'm using a measuring cup because then I can be a little bit precise about the amount of water that I'm putting in here. Because if I put one thing in 1/4 cup in here, so that's about 2 ounces in there, and then in the next one I'm going to put 4 ounces, and so now I've halved the space in there. So that's going to have twice the effect on the frequency. Now I'm going to put 3 cups in this one. 2, if I don't count out loud, I'm going to forget how many I put in. 3. 1. This is where I'm about to make a mess. 2. 3. Is there room for a 4th? I really hope so. Oh yeah. Oh yeah. Perfect. All right. So now, get the spoon out of there. So this one has 2 of those cups in it. This one has 4. And so this is working a little bit differently. You'll notice that the more liquid I put in, the lower the pitch of the sound. And when it's a little different, when I put more liquid in here, the pitch raised. So that's because it's working a little bit differently. When I put water inside the glass, that actually sort of absorbs and slows down the vibration of the glass. And because it's slowing down the vibration of the glass, that is lowering the pitch of the sound that it's making. All right, let's see. Okay, so I wanted to move on to the last part of this because we're already a little bit over, but I think we got some more time. Just a couple tips on going around your house and making instruments out of things you can find. One thing that's going to be really important is you want to give your whatever it is you're vibrating, right? What you're vibrating, that's sort of the engine or the soul of your musical instrument, because that's what's creating the sound. You need to give that a little room. And so you'll notice here this bell, for example. You see how it's hanging like this? And you get a nice clear sound. Now here's what happens when I hold the bell. Not such a great sound. And that's because my hand is absorbing all those vibrations, right? And so you want to give the thing that's vibrating a little room to breathe. Right? You can see the same thing when you look at a guitar, right? Is that it's really holding it at these two spots and then giving that string plenty of room to vibrate. So another example is, I built this earlier today. This is a coat hanger and cup measures. And I like the cup measures because then they all sort of have a nice incremental. And so one of the things I did is I made these little bends in the coat hanger, because if they all were touching, it gets all muddled and it's not a very clear sound. So you want to give everything room to vibrate. Another thing which can be good is that I want to be able to make it easy to be able to change or create different notes. And so this is a pretty simple, this is a rubber band. And you'll see here I have a little piece of wood, and this could also be a pen or really anything. And so I can just, like using your finger on a fretboard, I can slide this up and down. To make different notes. And you'll notice one thing is that my little rubber band one-string guitar is not very loud. So the other thing you can do is, you remember how we looked at the guitar, and the guitar has that hollow body with a hole in it. We looked at the horn and how it has that way of resonating and amplifying the sound. So we could find a similar way to do that. For example, if you had something like a bucket or a pot, you can, so, I don't know, maybe I'll move you a little closer if I can do so without spilling my beet juice xylophone. Maybe I'm the first person in the world to invent a beet juice xylophone. I hope they have a Wikipedia page for me someday. Okay, so, you can hear it there, but then now do you guys hear how it's louder now? So that's how I've sort of put together those different ingredients, is that I found something that vibrates. In this case, it's going to be a string. And I gave it sort of room to vibrate, and that it's not touching. If I put the string along here, right, there's no room to vibrate, because as soon as it hits the wood, it stops. So I give it a little room to vibrate where it doesn't bump into other things. And then I give a way to be able to change those vibrations. And then I give it a way to have resonance. So it's a little louder, and if I wanted to have a concert with an audience, it would be easier for them to hear it. And then the final bit of advice that I would give for building instruments out of things that you find around the house is experiment. I tried lots of different lengths of wood, and some rubber bands weren't really all that great, and others were better. I tried a bucket, I tried a pot, I tried a cardboard box, and I tried a lot of different things in order to sort of create resonance. And everything's going to have its own sort of ways of behaving and its own ways of working, so it's really important to try a lot of different stuff. And that's sort of how you're going to figure out. You're going to make some instruments and you're going to listen to it and you're going to be like, ooh, that is rough. And then you'll make other instruments and you'll be like, ooh, that sounds great. So it's all about that experimentation and sort of seeing what you can discover and what you can make. I've had a lot of fun exploring sound with all of you. It's been really great. We've got a couple minutes left. I don't know if I can, if anybody has any questions, I can try and answer them. Otherwise, I wish you guys a wonderful, wonderful weekend. But I will stick around in case there are any questions before I go. And the other thing is that we will post this on the Loog Instagram account, so you'll be able to see it. You'll be able to watch it again, or sort of go back to things that you liked from it. And thank you all again for coming. It was a really fun way for me to spend a couple days hunting around the house, finding different ways to make sound. Thank you to Loog for giving me an excuse to geek out on sound and science. All right, so with that, I think I will serenade us out. As you can tell, I'm a little better at explaining science than I am at playing melodies. All right, hope everyone has a wonderful, wonderful weekend.